Sounds like a spaceship, looks like it should be in Tron.
Welcome to Third Angle. Today we get our hands on luxury electric motorbike, the Vector. I'm your host, Paul Hames from industrial software company PTC. In this podcast, we share the moments where digital transforms physical and meet the brilliant minds behind some of the most innovative products around the world, each powered by PTC technology. Streamlined, efficient, euphoric. ARC is a UK-based team that's reimagining the future of adventure, creating high-end, luxury electric motorbikes supported by PTC partner Root Solutions, part of the PDS Vision Group. ARC's first product, the Vector, is an elite motorbike that pushes the boundaries of our imagination. As a brand new project, it has no legacy to follow, so the team has had real creative freedom, going back to square one to design something truly unique. Just as every customer is different, every Vector will be unique as well. To find out how these bespoke machines are being crafted, our producer Hannah Dean visited ARC's HQ in Coventry to meet the company's founder, Mark Truman.
It's taken over my life for the last 5 years, to be honest with you. Definitely. Yeah, I've got a very long-suffering and very patient wife. So yeah, this is the design office. This is where sort of, most of the magic happens, I guess, in terms of the guys working on the bike and some of the other projects also that we're working on. We're obviously based on a manor house, effectively, and this is an old barn. I presume was kind of like the old stables or something along those lines. The building was built in, I think, 1647, and yeah, I mean, in terms of character, it's absolutely fantastic. We love all of the beams and sort of the way it looks. It's great. So I'm Mark Truman. I'm the founder and CEO of ARC. I've been running the business now since 2017, when we spun it out of Jaguar Land Rover. The project was actually started within the Jaguar Land Rover walls as a sort of secret project. So we would be involved in two types of work stream. One, something the company would ask us to do specifically. So for instance, designing the James Bond cars for Spectre. And we were the first people ever really to land drones on moving vehicles in a meaningful way for a search and rescue vehicle for the Red Cross. And then we would also basically do sort of what we consider the sort of true skunk works type work, which is we're working on it, no one really knows we're working on it, and we had a show that we had to do every year. And over the 12 months we designed and built an electric motorcycle that no one knew anything about. And then when we got to the show, we rode it out into the show to all of the board of directors. And that's basically how the business started. So, this is where the bikes will be built. Obviously each bike is sort of hand-built, bespoke for the customer. You'll see the commissioning suite in a moment, sort of colours, materials. You'll notice differences between this one, which has got a sort of traditional carbon fibre weave top, and also on the side there, on the monocoque. So pretty much everything you're looking at is carbon fibre. Yeah, so you can see the bikes up on the stand now. They're putting the integrated motor onto it now. Yeah, so the build begins. I love this bit. This is like really, this is what you do it all for. This is like the most exciting bit, But apart from riding them, of course, but, to actually see them sort of going into production is, it's fantastic. So I'm just about to start up the Vector now, and what you'll hear is us taking it through its startup process. Like a spaceship, right?
Yeah.
We just had the guy from Wired magazine riding it, and he just got off of it and went, sounds like a spaceship, looks like it should be in Tron. Because it was going to be a Jaguar product, there was a certain amount of Jaguar design language that we had to put into it, which isn't the way that personally I probably would have gone. Much more sort of flowing lines, that kind of sort of elegant sort of spaceship feel, I guess. Whereas I much prefer, from a design perspective, that sort of angular, stealth bomber, Lamborghini kind of design language. Lots of sharp edges, sharp lines, and the spin out from Jaguar Land Rover allowed us to move back into, that direction. I mean, the main USP of the bike is that there is no frame, there is no chassis. That is what really stands this motorcycle apart from anything else. You'd have seen, the other motorcycle that we had in the workshop. That's an electric bike. It weighs considerably more than ours, even though ours has got more battery in it. And the reason that is because, someone somewhere when they built that bike said, right, we're going to build an electric bike. Well, we start off with a frame and then we're going to put a battery in it. And we said, well, do you need the frame? Because the frame was only really to join up some hard points and to hold an engine. And now we don't have an engine. So they've started with a frame, they've put a battery in it. Because all of that doesn't look that pretty, they're then going to put lots of covers on it. And they end up with something which is actually really big, quite cumbersome, and also really heavy. We said, what about if we just make beautiful batteries? And that is the frame. If you think about motorcycle, the custom motorcycle scene, it's not about covering things up, it's about being able to see the engineering. And we said, right, well, what about if we can do that with batteries? And one day, kids are going, have you seen that battery over there? Wouldn't that be lovely? One attribute that we wanted this bike to have was agility. It's an EV, so it's only slightly heavier than a petrol counterpart. We did as much as we could to keep the weight down, which is why everything on the bike is carbon fiber. But as a motorcyclist, it's not the moment when you're going 160, 170 miles an hour that you really enjoy. That's nice for a second. It's the bit where you're going around some really twisty bends, and the sun is out and there aren't many cars around, and you can, really sort of flick the bike from side to side and feel confident in it. And it's that moment that this bike was designed around, which is why we don't have telescopic forks on the front of the bike, and we've got hub center steering, which means that the bike is incredibly nimble, incredibly agile, can easily be flicked from side to side without, much input from the rider. And we've absolutely nailed it. I mean, we've had now riders, ex-MotoGP riders, which is kind of like the Formula One of motorcycles. We've had numerous motorcycle journalists as well riding the bike, and they all say the same thing, which is in that moment where you're changing direction, it changes direction like nothing else that they've ever ridden. Our job is to build the most coveted motorcycle brand in the world. I remember being a kid and having pictures of certain motorcycles and certain cars, as posters on my wall. I still want every one of those now. What we wanted to do here was to create something that it's not going to be a poster anymore, it's going to be a screensaver or something, right? But, that a kid has got on his screensaver, because that provides the longevity of the brand, because those guys and girls grow up, aspirationally wanting, your product. In terms of inspiration specifically for the bike, we had two really. One was we wanted it to be, have a sort of cafe racer feel. And the other one was we were looking for certain items to take inspiration from. And we really focused in on electric violins, because one, they're such beautiful things generally. And we really just loved the sort of mix of art and technology. Everything that is needed to perform the art is, still there, but everything that is kind of surplus to requirements now in a new electronic world has been sort of taken away. And that was very much the inspiration for the bike, and, why there are holes in parts of the bike where normally there wouldn't be on a petrol version. And actually our super sport bike, which is the next bike that we're going to start to work on, has even got more of an inspiration, from those products. This is the commissioning suite, so this is where we take customers to spec their motorcycles, what colour and materials they could have, etc. And let's go and have a look, and you'll soon get a flavour for what it's like. It's also a bit of a taste of the unexpected, I think, right? this is the area where we're going to try and make their dreams come to life, and we need them to input, into that and get them to open up. It's really funny though, you get a real mix. Some people come, they know exactly what they want, right through to people that come, they haven't got a clue what they want. We get calls from people like, maybe I've had a couple from young crypto millionaires, that are sort of like 16, 17 years old, have enough money to be able to buy one of these things. They'll sort of say to me on the phone, "Oh, do you think it's okay having one of these as my first bike?" And I'll say, absolutely not. Buy something cheap that you can afford to fall off of a few times, because it will happen, and then come back and see us. But, people just really want to buy into it. And that's one of the reasons we started this brand was, motorcycle numbers are dropping, in the Western world. And people are they're more interested in technology and connectivity and, all of those aspects. So we wanted to create a product, we sort of say, for the PlayStation generation. Something where there's a huge amount of connectivity to kind of try and draw some of those people back into, our motorcycling space. One of the things, that we're doing is we're not just developing a motorcycle. We're actually developing a head-up display helmet and a haptic jacket as well. So a haptic jacket that will give a rider a tap on the shoulder, for instance, when their sat-nav wants them to turn left, trying to stop them having to keep looking down at, their screen, which for a motorcyclist is more of a dangerous and time-consuming thing just because of the angles involved than someone that's driving a car and it's almost kind of in the eye line. So we've just started something that we call the AE program. We've just launched this. This is 10 customers, 10 limited edition bikes that will have sort of details on them that won't be replicated ever again anywhere else. Those customers are going to help us with the creation and the development of the head-up display helmet and the haptic jacket. So it's a 2.5-year program. They'll receive their bike. They'll then be involved in track days, so they can test the system in a closed circuit environment. When we then believe the system is ready, they'll receive a beta version of it for them to, again, try on the road and to provide additional feedback into the system. How does it perform in a real world environment? And then when the system is completely signed off for production, those customers will receive the system free of charge. They'll kind of have their name on it as well somewhere, as if to say, I've helped design this and I'm going to help save lives. And then it will become an optional extra on our other products. Initially, when we first thought about the system, to be honest with you, we didn't start off about saving lives. It started out about feedback from the motorcycle. So one sort of negative, if you like, or something that is lost with electric motorcycles and cars, in fact, is that, you've lost a lot of those physical cues that tell you things like, how fast am I braking? How quickly am I decelerating here? So when we first benchmarked a load of electric bikes, when we very first started this project, we'd be riding along, we'd got a couple of motorcycles which we'd borrowed, we'd get to a corner, and we'd either find we were going dangerously too quick when we got there, or we were going so slow it was almost like driving Miss Daisy, around the corner, and we couldn't understand why we couldn't judge it correctly. And we started to realise it's because, on a petrol bike, you've got gears. You've got engine braking, you've got vibrations, you've got noises. On one of these, you've got one gear, very little noise, no vibration, pretty much zero engine braking. So you kind of come in there silently, and it's very difficult at first to understand how much speed you've scrubbed off and to get it just right. And so we thought about, how do we start to give a rider some feedback? And so we started playing with haptics. So in sports mode, imagine a jacket that is full of phones on vibrate. You've got them in pockets everywhere. And the harder I brake, or the harder I accelerate, or the tighter I'm turning, the more those phones are on vibrate. So much so that if I'm braking really hard and the bike knows that you're close to locking the front wheel, which is probably the worst thing you can do on a motorcycle, your jacket will be going crazy and you'll be going, okay, I'm on the limit here. So that's how the system started. It was a really interesting process, looking at different haptics. And I remember explaining it to my boss and him thinking I was absolutely crazy, I think, at the time. I'd just been through some haptic experience where I was in virtual reality as well, and I ended up sort of in a lake, and a train came across the lake and hit me and burst into lots of birds, which turned into ribbons, which created a tunnel, and I went through the tunnel. I ended up in a womb with a baby. And I remember telling him that exact story, and him kind of looking at me to say, I'm paying you too much and you're maybe taking something you shouldn't be. And, sort of talking him into allowing us to continue to look at this. And it was really interesting. We found that playing music through the haptics actually gave you the same emotional response as if you were listening to it, because things were happening and all of a sudden you'd have like hair stand up on the back of your neck. And then we started to realize we could do more with the system. So now the system's got 3 modes. It's got sports mode. We started to realize that it could be used as a safety thing, sort of taps on the shoulder, blind spot monitoring. It's got the same system as your car might have, where a light comes up in your wing mirror to say there's a car overtaking you or behind you. But instead of a light coming up, you'll get a tap at the back of on the bottom of your spine, on the side that the car is approaching. That tap will get further up your back the closer the car gets, and the speed that it will go up your back will obviously give you an idea of the closing speed of the car. So this is all about allowing the rider to keep focused on what they're doing. And then we created this 3rd mode, which we learned by accident, which we call euphoric mode, which is basically designed to make the hairs on the back of your neck stand up, based on these experiences that we had. And so you can download 5 tracks of your sort of all-time favorite feel-good tracks onto the bike. And when the system's completed and finalized, if you're having one of those wonderful twisty road sunny day moments where you think you're Valentino Rossi, you can press the button and it'll essentially play that music through your jacket, and just about giving you sort of 1 minute of a sort of an amazing feeling.
That was Mark Truman, CEO and founder of ARC. Now, as we've heard, the ARC Vector is the world's first fully electric neo-café racer, built to offer a futuristic vehicle whilst retaining some retro flourishes. That can only be achieved by using first-class design tools like PTC's 3D computer-aided design software, Creo. Let's find out more, and it's time to meet our expert, Brian Thompson, who heads up PTC's CAD division. So, Brian, can you tell us a little bit about how Creo works and helps them achieve that end goal?
Yeah, sure. I'd love to. So Creo is PTC's flagship 3D CAD product, and it's got the ability to help design engineers conceptualize and develop their designs in a digital world in 3 dimensions. You can imagine a full 3D model that looks like a clay model, but is only represented digitally in the screen. Whatever manufacturing process the design engineer is looking for, they can build 3D models that are intended for those processes directly inside Creo, make sure they work out all of the potential issues that might come up with manufacturing those designs, or even check if the designs will meet certain, structural or thermal requirements using simulation technologies, with the benefit of it all being in digital, because if you're going to make a mistake, that's the place to make it. You don't want to make a mistake with parts you have to manufacture. That is the power of what 3D CAD can do. But the design technology has evolved over time. Most engineers today still use many, many years of experience and intuition and instinct and knowledge about manufacturing processes that they know well, and they will design their parts thinking about those things from the beginning. And sometimes their own personal experiences can make them not think maybe as broadly as they could about certain design aspects of the parts they're working on. And you can imagine a company like ARC having very, very tight requirements, right? I mean, they're developing an electric bike here. So new technologies are emerging into the marketplace. We actually have them integrated into Creo. They're so-called generative technologies, use artificial intelligence to actually, instead of forcing the design engineer to worry about creating geometry from the beginning, what generative technologies do is they say, why don't you give me the space in which you want your part or assembly to exist, and give me the engineering requirements of that design. Like, what are the structural loads the design has to carry, the forces that it must carry? What are the thermal requirements of the design? What kind of natural frequencies, which could be really important for a bike, by the way, what kind of natural frequencies do you want to avoid with the design? You put all that into a blender, and the AI technology will create geometry for the design engineer to consider as a potential solution to that design problem. So now we've got 30 years of experience in helping design engineers build really good geometries for manufacturing processes. And now for the last several years, we've been layering in new technologies like generative that actually work side by side with the engineer and give the engineer some really cool, innovative ideas on how to accomplish certain design tasks that maybe the engineer would not think of. So we're really on a great journey here. I'm really excited to see ARC using all these technologies in Creo.
Now, I want to just turn to the notion of collaboration, because a product like Vector is not the work of one man. It's the work of a number of people plus a supply chain. Now, within Creo, ARC are certainly using the collaboration tools in Creo to foster that degree of sort of data sharing. Can you talk a little bit about the tools available to them and how that works?
A product like a motorcycle has a combination of different types of parts that are naturally going to be designed by different types of people. You're not going to have the same design engineer that designs the suspension of the motorcycle as the design engineer that designs all the cowlings for the motorcycle that help it slip through the air as efficiently as possible. Those are generally two different types of design profiles, right? But what you really want is you really want them working on a singular design. And you want to make sure you can share the different interfaces between the different parts of the design amongst the entire team, so that different members of the design teams understand, hey, I'm working within these boundaries. I have these interfaces that I have to attach to. And as long as I stay in this area, I can work. And oftentimes in those kind of scenarios in Creo, we call it a top-down design methodology, where you have an overriding architecture of the design that's established in Creo. And then you share out these interfaces to the various design engineers that are contributing to the design. And this top-down design methodology keeps control over how all those interfaces are related to one another, and how all the underlying designs, suspension, battery case, seat, cowlings for the shape of the bike, how all of that marries together into one solid architecture. It's something that we're actually really well known for in the industry, that we've developed over many, many years. And it's excited to see a new customer like ARC taking advantage of frankly the decades of experience we have in helping customers work this way.
Yeah, perfect. And again, they're creating a simply fantastic looking product as well.
It's super cool looking. It really is. They've done a nice job.
Thanks to Brian and to Mark for showing us around ARC's headquarters. Please rate, review, and subscribe to our bi-weekly Third Angle episodes wherever you listen to your podcasts, and follow PTC on LinkedIn and Twitter for future episodes. This is an 1860 production for PTC. Executive producer is Jackie Cook, sound design and editing by Oli Guiu, location recording by Hannah Dean, and music by Rowan Bishop.